Hello everyone, welcome to yet another session on learning about Ethereum. In this session, we learn about Introduction to Security Compliance Standards. Understanding security compliance standards is essential for creating secure and compliant smart contracts. These standards offer guidelines and best practices to minimize risk and vulnerabilities. By adhering to these standards, we can ensure the security and reliability of our smart contracts, thereby protecting our assets and user data. Moving on, we have why security compliance matters. Security compliance is crucial for developing robust and trustworthy smart contracts. Following these standards helps user mitigate vulnerabilities and safeguard the integrity of our contracts. Adhering to security best practices not only enhances user trust but also ensures legal compliance. Additionally, demonstrating our commitment to security can provide a competitive edge, attracting more users by building confidence in our project. Moving on. Here we'll see the overview of common standards. These are ISO/IEC 27001, NIST Cybersecurity Framework, that is CSF, CIS controls, and OWASP. We'll learn about all these standards in the upcoming slides. Moving on, we have the ISO/IEC 27001 first. It is a globally recognized standard for information security management systems, ISMS. It provides a framework for establishing, implementing, maintaining, and improving an ISMS. The standard helps organizations identify, assess, and treat information security risk, and addresses a wide range of security controls, including access control, cryptography, physical security, and incident management. The NIST Cybersecurity Framework (CSF) is a comprehensive approach to managing and reducing cybersecurity risk. It consists of 5 core functions: identify, protect, detect, respond, and recover. These functions help organizers understand their cybersecurity risk, implement safeguards, detect incidents, respond effectively, and recover from disruptions. The CSF is widely adopted across various industries, demonstrating its effectiveness in mitigating cybersecurity risk. CIS controls are a framework of best practices for cybersecurity, focusing on actionable steps to protect against common cyber threats. Organized into 3 levels, basic, foundational, and organizational, the controls provide guidance on implementing security measures. The basic level includes essential security measures, while the foundation level and organization level offers more advanced controls for higher security needs. CIS controls are designed to be flexible and adaptable to different organizations and industries. OWASP, that is Open Web Application Security Project. OWASP is dedicated to improving software application security by providing comprehensive resources and best practices. The OWASP Top 10 list identifies the most common web application security vulnerabilities. OWASP resources, including coding standards and security testing tools, help developers build secure applications and mitigate vulnerabilities, enhancing the overall security of software applications. Moving on, we have relevant standards for smart contracts. For smart contracts, relevant standards include EIPs, that is Ethereum Improvement Proposals, ERC standards for tokens, and best practices for secure smart contract development. EIPs. These define standards and improvements for the Ethereum blockchain, guiding developers towards best practices. ERC standards for tokens like ERC20 and ERC721 provide standardized interfaces for tokens on the Ethereum blockchain, ensuring interoperability and integration with various applications. Best practices for secure smart contract development. These include thorough code reviews, security audits, and rigorous testing to mitigate vulnerabilities and reduce the risk of attacks. EIPs, that is the Ethereum Improvement Proposals. EIPs are formal proposals for improvement to the Ethereum network, covering topics such as core protocol specifications, contract standards, and enhancement to the EVM, that is the Ethereum Virtual Machine. EIPs undergo a rigorous review process, ensuring that changes are well considered and aligned with the overall goals of the Ethereum network. An example is EIP20, which defines the standard interface for the ERC20 tokens commonly used to represent digital assets on Ethereum. ERC standards define protocols for Ethereum-based tokens, enabling interoperability and fostering a standardized environment for token creation. Key ERC standards include ERC20, 721, and ERC1155. ERC20 it is a standard for fungible tokens, representing assets with interchangeable value like cryptocurrencies. ERC721 standard for non-fungible token, representing unique assets such as digital art and collectibles, that is the NFTs. ERC1155. It is a standard for multi-token contracts, allowing the creation and management of multiple token types within a single contract, providing flexibility for diverse applications. Implementing the ERC token standard. This slide demonstrates the implementation of an ERC20 token using the OpenZeppelin library. The smart contract MyToken inherits from the ERC20 contract provided by the OpenZeppelin, which implements standard ERC20 functions like transfer, balance off, and approve. The constructor initializes the token with a specified initial supply and assigns it to the contract's creator. Using the OpenZeppelin's library allows developer to quickly implement ERC20 tokens while ensuring compatibility and interoperability within the Ethereum ecosystem. This code defines a simple ERC20 token. The MyToken contract inherits from the ERC20 contract, and the constructor sets the initial token supply and assigns it to the creator's address using a mint function. By leveraging the OpenZeppelin library, developers can quickly and efficiently implement their own ERC20 tokens while adhering to the established standards. This ensures compatibility and interoperability with the various decentralized application exchanges with the Ethereum ecosystem. In Secure Software Development Lifecycle, that is the SDLC. Integrating security into every phase of the software development lifecycle, SDLC is crucial for building secure smart contracts. The secure SDLC approach ensures that security considerations are embedded throughout the development process, from requirements gathering and design to implementation, testing, deployment, and maintenance. By proactively addressing security concerns, developers can mitigate vulnerabilities and reduce the risk of attacks, resulting in more secure and reliable smart contracts. Security by design. Security by design emphasizes incorporating security considerations during the design phase to prevent vulnerabilities from becoming significant issues. Threat modeling is a key component, helping developers identify potential threats and develop mitigation strategies. Secure design principles such as input validation, output sanitization, and access control mechanisms are essential for creating secure and trustworthy smart contracts. Moving on, we have code review and audits. Code reviews and audits are vital for identifying vulnerabilities and ensuring the security of smart contracts. Peer reviews involve other developers examining the code for potential issues, while automated tools provide comprehensive analysis. Static analysis tools detect errors without executing the code, and dynamic analysis tools evaluate the code's behavior during runtime. Engaging third-party auditors can provide an independent assessment of the code security, helping to identify risks and vulnerabilities that may have been overlooked during development. Moving on, we have testing and validation. Through testing and validation, we ensure the smart contract function as intended and are resistant to vulnerabilities. Testing should include unit testing, integration testing, and first testing. Unit testing verifies individual components, integration testing assesses component interaction, and first testing involves providing random inputs to uncover vulnerabilities. Deploying contracts on test nets before the mainnet allowed developers to stimulate real-time world conditions and identify potential issues. Moving on, we learn about continuous monitoring and updates. Continuous monitoring and updating of smart contracts are essential for maintaining security and reliability. Monitoring tools track contract activity to identify suspicious behavior or vulnerabilities. Regular updates and patching protect against emerging threats. A well-defined incident response plan outlines steps to address security breaches, including investigation, containment, remediation, and recovery. Implementing a robust monitoring and update strategy ensures ongoing security and resilience of smart contracts. Moving on, we have documentation and transparency. Clear and comprehensive documentation is crucial for fostering trust and accountability in smart contract development. Documenting the code, security practices, and compliance measures helps users, auditors, and other developers understand and interact with the contract. Transparency builds trust in the blockchain system, enabling users and auditors to assess the contract security and reliability. Detailed documentation also facilitates collaboration and knowledge sharing within the development community. Moving on, regulatory compliance. Ensuring compliance with relevant laws and regulation is crucial for building secure and trustworthy smart contracts. This involves understanding the regulatory landscape specific to blockchain technology and smart contracts. Regulations such as the General Data Protection Regulation (GDPR) for data privacy and anti-money laundering, Know Your Customer (AML), that is the KYC for financial transparency, may apply. Collaborating with legal experts specializing in blockchain compliance is essential to navigate these regulations effectively. Moving on, we have case study, that is a compliance in action. A DeFi protocol on Ethereum implemented the ERC20 token standard and adopted the NIST cybersecurity framework to guide its security practices. The protocol underwent thorough code reviews and audits, identifying and addressing vulnerabilities. Continuous monitoring and updates ensure Ongoing security. This comprehensive approach helped the protocol build trust with users and establish a robust DeFi ecosystem, highlighting the importance of continuous security improvement and compliance. Moving on, we have the conclusion slides. Integrating security into every phase of the software development lifecycle is a critical step towards building secure smart contracts. Implementing these practices will help ensure the security and resilience of the smart contracts. Remember to stay updated on the latest standards and regulatory changes and apply them to all your projects to improve the overall security of the blockchain ecosystem. Continuous improvements is essential. Regularly review your security practices, update your code, and stay informed about emerging threats and vulnerabilities. Thank you and have a great day.